Advances in aviation history give way to legendary aircraft that become the most powerful and innovative weapons of our time. Each airframe is unique, with limitless capabilities. But one thing remains the same. Underneath the surface, they are all simply great planes. On May 1st, 1965, an American plane designated the YF-12A sets 4 world records, 1 for sustained altitude and 3 for speed, including a mark of 2,070 miles per hour. While Washington hails the achievement, the event does nothing to brighten Moscow's May Day festivities. I'm Paul Max Moga, and this is the Virginia Aviation Museum in Richmond, Virginia. Join me as we hear the declassified story of the SR-71 Blackbird. Lockheed Blackbirds, built with radical new methods and materials, astound even the experts. Designed under a top-secret program, they seem to come out of nowhere. There is no one better to help us tell this story than Buzz Carpenter and Blair Bozak. Buzz and Blair, I appreciate you guys being out here today to talk to us about the beautiful Blackbird.
We're glad to be here.
Now, you guys have quite a bit of history with this plane. Just tell me real quick what your background is with the SR-71.
I came out of the RF-4 in 1975 and flew the Blackbird for 6 years and ended up as an instructor pilot before I left.
I left the F-4 in 1985 and then flew as a backseater, an RSO in the SR-71 from 85 to 90, program termination, and was one of 6 guys chosen in 1995 to come back and fly it again when Congress reestablished the program.
So if anybody knows something about this plane, it's probably you guys.
We hope so.
Great. Yeah, you look at the plane itself, and it is probably the most unique shape of an airframe that we've ever seen out of an aircraft. So tell me a little bit about what you know about just the basic design shape.
Basic design shape, it was a challenge that went to Kelly Johnson. President Eisenhower was appraised that the U-2 was at risk, was going to be shot down at some time in 1957. There was a competition, and it came back and said, you need an airplane that can fly, not at 450 miles an hour, but at 2,100 miles an hour, Mach 3 plus. Not at 70,000 feet, but above 80,000 feet. And also you need to create America's first stealthy airplane.
From the beginning, the program was covert, hiding behind the codename Oxcart, which conjures up the opposite image of lightning-fast, high-tech aircraft. For almost 2 decades, the military manages to ensure that not every detail is classified, but not every fact is necessarily accurate. An SR-71 stretches 107 feet long, stands more than 18 feet high, and has a 55-foot wingspan. Instead of armament, it carries cameras and other sensors. Empty, it weighs over 67,000 pounds, with a maximum takeoff weight of over 172,000 pounds. And it can carry its 3,500 pounds of reconnaissance equipment for 3,250 miles without refueling. Guys, this is one wicked-looking engine. Tell me what you know.
This is really the heart of the system, because the genius of Kelly Johnson, Ben Rich, who was his deputy, and Pratt & Whitney, all airplanes prior to this, they kept the shock external, because no engine, turbo engine we have today can...
Shock wave.
The shock
Supersonic
wave
shock
cannot
wave.
absorb. You have to have subsonic air that's fed in. So this is a spike, much like you have ramps on F-4s or on F-15s. This is a subsonic position. When you hit 1.6 Mach, you have to slow that supersonic air so the engine can absorb it. So this starts traveling aft. It goes aft as 26 inches. It doubles the hole size. And the back of it acts like a compressor. So as the back constricts to 50% of its original size, and this opens up to 110%, so now you're getting mechanical compression. So at altitude, we actually had more pressure against the face of our compressor blades than we had here on the surface of the Earth at sea level. The shock was carried inside. This airplane is the only airplane in the world that I'm aware of, Max, that the faster we went, the less fuel we burned, because
That is counterintuitive.
it
to a
becomes
fighter
more
pilot.
like a ramjet. 82% of your thrust at 3.2 Mach is ram thrust. So the engine's really only producing 15 to 17%. That's the most effective use of fuel that you can have.
So let me get this right. You would speed up to make gas.
Yep, correct. When Blair would say that we're short on fuel, if the temperature allowed us, you would accelerate and would raise your altitude, but also would lower your fuel consumption.
God, that's such a unique design. But I mean, you had to have it on this plane to allow it to do what it did.
To get to 3,000 miles that we guaranteed between refuelings, think of it this way. Every 2 hours, you either came down to refuel with a set of tankers or you were going to land somewhere. And in that time period, you went over 3,000 miles.
According to government figures, 32 SR-71s are built, but many suspect there were more. Blackbirds spring from the Cold War, when Soviet nuclear capability demands better intelligence gathering. The more facts, the less speculation, and the less paranoia. When President Eisenhower suggests an open skies policy to permit reconnaissance flights, the Soviets decline. But the president isn't inquiring, he's declaring his intent. The nuclear stakes demand that the U.S. fly reconnaissance, no matter how the Soviets feel. The U.S. needs a new plane for the job.
In the early 1950s, the United States had a real requirement to overfly Russia to find out the status of their development of long-range missiles. Lockheed made an unsolicited proposal to the Undersecretary for Research and Development for the Air Force on a very specialized airplane. The program was turned over to the CIA, who then followed through with the development of the Mach 3 Blackbird.
With the clock ticking, huge technological challenges to overcome, and the Cold War growing more bitter, Lockheed has its work cut out for itself. When President Eisenhower orders a surveillance aircraft to fly over the Soviet Union, he's asking Lockheed's design team, led by Kelly Johnson, for a lot. To fly over the USSR, the plane has to cruise beyond the scope of interceptors and anti-aircraft weapons. And with no fuel stops en route, it has to have a very long range. Lockheed's first crack at the design challenge produces the famous U-2. The first prototype U-2 arrives at the test site on the 29th of July, 1955. The designation U-2 gives nothing away about the top secret project. The U stands for utility. As the U-2 starts performing roles beyond its primary espionage duties, utility becomes an accurate description. Maneuvering a powered glider in extremely thin air at great altitude places new demands on the pilot. At altitude, the stall speed is dangerously close to the plane's entry into transonic flight, the point at which supersonic airflow over the wings begins. In the U-2, at 70,000 feet, these 2 points are about 12 knots apart. Below 400 knots of ground speed, you would fall out of the sky looking for denser air. Above 412 knots of ground speed, your wings might come off. Over the years, with increased load and more powerful engines, the gap actually narrows to less than 5 miles per hour. Due to the stress of the missions and the fragile nature of the planes, U-2s aren't expected to have long lifespans, particularly when the Soviets start trying to knock it out of the air. The top-secret design team, led by Kelly Johnson, was nicknamed Skunk Works, after the mysterious place deep in the forest cited in a Little Abner comic strip. When the Soviets design effective weapons to intercept the U-2 reconnaissance platform, the time comes to replace them with something faster. Kelly Johnson's team dreams of a new concept that can deny interception and take it to the next level technologically. In 1958, even the most advanced fighter designs can't beat Mach 2. So everything about this airframe will have to be revolutionary. It takes Johnson and his team 11 unsuccessful designs to get the combination of features right. On August 29, 1959, their 12th submission, the A-12, wins limited approval. The new airframe has 4 large equipment bays to handle specialized reconnaissance and surveillance gear. Now, Blair, I assume that the nose of the aircraft wasn't a luggage compartment like it is with some of the other ones. So, did it have a radar in it or something else?
The primary sensor was always in the nose, and this nose is actually held down by just 4 bolts. The primary sensor was the radar most of the time, and if we did not operate a radar, then there was what was called an optical bar camera sitting here with lenses on both sides that would give you a continuously rotating camera lens, giving you horizon-to-horizon coverage. It was that camera system that gave us the 100,000 square mile per hour synoptic coverage capability.
Unbelievable.
With the radar, as at least when I retired a couple of years, or 10 years ago now, at the unclassified level, we had 1-foot radar resolution with the SR-71 radar.
So it was a ground mapping radar.
That's exactly right.
No air-to-air capability
Correct.
whatsoever.
Correct. And so even the air refueling rendezvous were done visually, even at night.
So that was sporty.
We had some electronic aids, but you did not have a radar.
Nobody ever goons up with tanker rejoin at night, do they?
No. In addition, besides the primary sensor of either the nose radar and the optical or the optical bar camera, there were the potential for 2 technical objective cameras, one on either side of the fuselage in the chine in one of the equipment bays. We'll show you that later on. And then we also carried an ELINT package on the airplane. So on any one mission, you could potentially have ELINT, photo imagery, and radar imagery.
Mission equipment also includes side-looking radar, a terrain objective camera, 2 operational objective cameras, 2 technical objective cameras, and infrared mapping mission recorders, and an EMR system. To carry it all, Johnson designed a blended body and delta wing, incorporating 2 huge engines. The flat profile of the forward fuselage reduces the Blackbird's radar visibility, while creating extra lift to carry fuel and the payload. Now, Blair, this has got a pretty unique shape to it. It's really flat. I mean, almost like a platypus or something like that. What's the genesis behind the actual shape of the plane?
The The chine, which is this area from the nose all the way back through the delta wing, is essentially a large canard. And it's giving the airplane that much more lifting surface so that we've got a minimum drag situation that also has a minimum trim drag on the elevons at supersonic speed.
So it's like a giant flying wing with a couple of huge engines on it.
Yeah, it's like a speedboat. In fact, we fly with a deck angle where subsonically, if you're in the pattern, a T-38 flying next to you is going to be nose down, hunkered down. We're sitting like this. And it's kind of funny to watch the two airplanes driving by. And the SR is always sitting like this, but it just happens to be, rather than driving a wake off the nose of the boat,
yeah,
it's got a shock wave going, you know, from 80,000 feet down to the ground.
The engines, positioned midway along the wing, are housed in nacelles that have unique intake systems to control airflow, critical in generating the plane's amazing power.
You look at the boat-like shape that you see down here, Max, that it looks like the engines are drooping, but actually at cruise, the nose is always 2 degrees up, so the engines are level. And that was part of the design. As you burned off fuel, you continued to climb, and it gave us the efficiency for the intercontinental range.
For speed, the Blackbird has very thin wings that can be used for fuel storage, but the plane carries most of its fuel in the fuselage. On January 30th, 1960, the CIA orders 12 models. The original concept yields 4 models: the reconnaissance A-12 version, the long-range YF-12 interceptor for the Aerospace Defense Command, the refined reconnaissance version SR-71, and the still highly classified D-21 espionage drone. Literally everything on the aircraft has had to be invented from scratch, including the paint. Yet the first plane flies 2.5 years later. Lockheed has some experience with titanium fabrication, but nothing like what they need for this job. The plane has to withstand very high temperatures for long periods. Parts of the skin will reach between 800 and 1,000 degrees Fahrenheit at Mach 3. Despite the expense of titanium alloy and the research and development costs of inventing it, it makes up around 93% of the aircraft.
What Kelly Johnson and the team had to design to figure out how you work in that environment, that's why 93% of this airplane's titanium.
And how about the color? I mean, it's obviously, hence the name Blackbird, but was there a purpose behind the color besides just wanted to make a plane black?
The basic airframe as initially designed in the A-12 sister aircraft was bare titanium. And by painting it this black paint, they were able to reduce the overall temperature of the airframe about 50 degrees Fahrenheit.
As Lockheed learns, metals designed to operate under extreme conditions require extreme conditions to fabricate. Some major parts have to be shaped in huge custom-built presses, operating at 1,500 degrees Fahrenheit. Hot forging the metal in specialized equipment is only the first step. Then the forgings are machined to extremely fine tolerances. Lockheed develops tape-controlled robot cutters to handle the metal and a new cutting fluid that doesn't corrode the titanium alloy. Each step of the plane's development requires either a new or a specially adapted process. Early in the project, Kelly Johnson jokingly offers $50 to any staff member who can come up with an easy problem to solve. Each Blackbird comes together as a series of sub-assemblies. The fuselage and wing components are each produced in 2 sections to save man-hours and optimize assembly space. It's not just the plane's skin that has to withstand temperatures up to 900 degrees. Somehow the engineers also have to protect the plane's intricate web of wiring. And then comes the testing, simulating the aerodynamic loads the aircraft will face in flight. But in the late 50s, there is still a huge gap between theory and practice. When all is said and done, will the Blackbird fly? In 1979, the U-2 was rechristened the TR-1. TR-1s still fly electronic and communications intelligence missions. To fabricate the supersonic Blackbird, Lockheed has literally reinvented the wheel. Individual components are tested to the breaking point. Violent landings and lateral stresses torture the landing gear, the tires, and the brakes. On the 30th of September, 1964, the press gets its first look at the YF-12 Blackbird. Then Air Force Chief of Staff General Curtis LeMay successfully lobbies President Johnson for a Strategic Reconnaissance, or SR, designation for the aircraft. Unfortunately, materials handed out to the press hadn't been changed from the proposed RS-71 designation, giving rise to the myth that the name of the aircraft was the result of a presidential gaffe. During the presentation, journalists study the plane up close, meet its makers, and watch a flight demonstration. The Blackbird is sold to the press as the latest long-range interceptor. But this claim is not just a cover story for its intelligence-gathering role. The only problem is that an interceptor catches the enemy and shoots him down. But when the fighter flies faster than a bullet, guns aren't much use. Rockets capable of launch at Mach 3 don't exist in 1960. So once again, the Blackbird demands another invention. The Hughes Aircraft Corporation designs and successfully manufactures the AN/ASG-18 Pulse Doppler radar and AIM-47 air-to-air missile system for the YF-12. Politics ensures that the Blackbird is never used as an interceptor, but the missile gets refitted as the AIM-54 Phoenix system for the F-14 Tomcat. The highly advanced SR-71, the most advanced plane of its time, didn't fit the interceptor bill. Kelly Johnson builds only a small number of his masterpiece aircraft, and under the tightest security possible. Limiting production to the reconnaissance version shrouds the Blackbird in mystery. The SR-71 celebrates a successful maiden flight on December 22nd, 1964. The SR-71 heads to acceptance tests at Edwards Air Force Base on August 13, 1965, and then into service. Enough information about the Blackbird seeps out to make them one of the most well-known secrets in the world. Aircraft enthusiasts come to appreciate it based on the little they've learned. Then, in September 1974, the Farnborough Air Show gets a special visitor. This heightens international public interest in the unusual aircraft. The SR-71 Blackbird was the winner of the prestigious Collier Award, which recognizes the greatest achievements in aeronautics or astronautics in America, with respect to improving the performance, efficiency, and safety of air or space vehicles. The SR-71, flying from New York to London in 1 hour, 54 minutes, 56.4 seconds, sets a record and thrills aviation fans. Whenever the SR-71 makes a rare appearance at an air show, the crowds follow. On its way back to the U.S. after the 1974 Farnborough International Air Show, the SR-71 sets another record, London to Los Angeles in 3 hours and 48 minutes, including a rendezvous for in-flight refueling. In terms of local times, it arrives about 4 hours before it takes off. Prior to that, on April 26, 1971, this very Blackbird covers 15,000 miles in 10.5 hours non-stop, the equivalent of flying from San Francisco to Paris and back. The U.S. Air Force flies its SR-71s with the 9th Strategic Reconnaissance Wing based at Beale Air Force Base in Northern California. They received their first Blackbirds in January 1966. In the next 24 years, they fly thousands of long-distance missions. To fly the SR-71, pilots must pass rigorous requirements, similar to the astronaut program. But the aircraft has no fancy escape capsule. Kelly Johnson believes that the spacesuit offers enough protection from the environment.
The suit was designed for the entire envelope of the airplane. Wow. And because you're in a full pressure suit, then if you had to eject or you just lost your canopy in flight, you had the systems and the backup systems to keep the proper pressurization for your body and the proper oxygen flow.
So you guys could be up there in the nosebleeds going Mach snot, and if you need to get out of the plane, you'd make it. You'd have a long trip down.
You'd have a long trip down.
But you can make it.
Exactly.
The trick to survival is getting the pilot clear of the plane at Mach 3. It requires a specially designed ejection seat and parachute. Of course, you can't simply take a Blackbird up to Mach 3 at 80,000 feet and shoot the crew out to test the escape system. Some things have to run on faith. Now, Blair, I'm going to ask you this one because I know you have a personal experience in this realm. What's the ejection seat capability of the Blackbird? 1, 2, is it a 0-0 ejection seat?
The Blackbird's ejection seat is a Lockheed seat, very comparable to an Aces II or a Martin Baker seat. We in the Air Force Blackbird program never lost a crew member. We had our share of ejections, and where my name is associated with that was an ejection on the 21st of April 1989 on an operational sortie out of Kadena. So my pilot, Lieutenant Colonel Dan House, and I had the last ejections out of the Blackbird program. In our case, it was a engine seizure at Mach 3 and about 75,000 feet. That eventually took out the flight control hydraulic systems, and when the airplane became uncontrollable, we stepped over the side at about 12,000 feet and about 350 indicated. Dan gave the command. I wasn't in position as the airplane pitched up. He went first. I got in position. I followed him. So I indeed, by about 2 seconds, had the last ejection of the Blackbird.
Over the years, at least 11 SR-71s and several crewmen are lost. But that doesn't mean pilots aren't clamoring to fly one. Pilots say that each airframe develops its own personality, maybe due to the fact that each aircraft is hand-built. What's more, each flight above Mach 3 retempers the airframe's alloy, theoretically giving the planes the strength to go on forever. Now, Buzz, this seems to be a pretty typical looking pitot tube, but there's an additional offset one on the side. What was that used for?
Max, this is a standard pitot tube like you'd have on most airplanes. The shock wave, when you're traveling at Mach 3 plus, is up here, but this is a beta probe, and you notice there's a hole on the top and on either side, because to make this airplane as maneuverable as it is in the environment, it's unstable in pitch and yaw. So as the air is flowing across this probe, it's constantly feeding the computer, I'm okay, or I'm not okay, and it's putting in small inputs to keep the aircraft under control.
So that basically yaw sensor keeps the aircraft stable as it's maneuvering, and that's done by the computer.
Exactly, because like I said, it shows negative stability in pitch and yaw.
So they had a flight control computer way back when in the SR-71. It sounds like it's pretty similar to some of the more advanced fighters we have now.
It is, and this started out, this first flight of the prior airplane was in 1962, so they were working on this technology way back when.
Kelly Johnson wasn't a dumb guy, was he?
Kelly Johnson was a brilliant genius.
So this was actually a first-generation flight control system which probably was used in the development of the modern-day ones, or in the planes that I fly, where the computer controls the stability of the airframe. And if you don't have the computer working, you got a lot of work to do.
I think some of the things I learned from this program actually led eventually to the fly-by-wire that we had experienced in the F-16 and eventually lead into where you are in the Raptor.
The Blackbird's corrugated skin expands at Mach 3 heat. To save weight and complexity, the skin also forms the fuel tanks. Fuel actually leaks from an SR-71 until the skin heats up, expands, and seals the tanks. The plane refuels shortly after each takeoff. It requires a specially formulated fuel that won't ignite in the hot tanks and that will burn at high altitude. And once hot, Blackbirds stay hot. Even after landing, the plane's too hot to touch. Selection for SR-71 pilot training takes about a year. Top gun types are weeded out. At over 30 miles per minute, there's no time to correct a mistake, and no place for cowboys. Operations demand a steady, team-oriented temperament. pilot instruction requires special training. No ordinary simulator can prepare a pilot for the SR-71. The instructor sits in a second cockpit tiered above the normal one. Any bigger and it would compromise the plane's supersonic ability. The A-12 trainer, nicknamed the Titanium Goose, can only top out at about half the aircraft's true speed of over Mach 3. Now how about the cockpit and the canopy? That doesn't look like a very big space for me, and I'm not, you know, a 300-pounder, so.
If you sat in it the way you are now, you would even feel a little cramped. But now put yourself in a pressure suit that weighs 45 pounds and a 10-pound helmet. You can't see aft to here at all. And you do most of your visibility as a pilot in the front, looking through that little pie window up there.
Yeah.
To do your refueling, to come into land. And that window, because of the heating that Blair talked about, that window's 620 degrees.
Serious SR-71 pilot candidates log over 3,000 flying hours. About 3 jobs open each year. One pilot, Colonel Robert Powell, logs 1,020 hours in the SR-71, giving him more time above Mach 3 than any other pilot in the world. He flies over 1 million miles and earns 17 air medals and 2 Distinguished Flying Crosses. For all its positive features, the Blackbird becomes troublesome to maintain and more expensive to fly. Portions of the upper and lower inboard wing skin of the SR-71 were corrugated. By making the surface corrugated, the skin could expand vertically and horizontally without overstressing. So when you're flying the plane, does it go through the computer? Do you have any direct control over the control surfaces, or does the computer basically augment you as a pilot?
The computer augments, because the flight controls in the cockpit, the stick that you had, because this aircraft has a stick, I had direct controls for pitch and roll and for yaw, but the computer was always working in the background to dampen any movement to make sure I didn't get into an unstable regime.
Now, would it ever get to a point where the computer would override you?
The computer would override you if you decide to pull the nose up too fast, like a closed pattern. There was a pusher in this airplane that could literally knock the stick right out of your hand.
Back off, stupid, I got it.
You got it, that's right.
That is still around today, I can tell you that. For all its innovation, the Blackbird must be constantly upgraded to advance with the times. As computers become smaller, the functional capabilities of these big spies increase. While an SR-71 has long been able to survey 100,000 square miles of territory per hour, the amount of information it can gather from that territory has grown considerably. When work on the Blackbirds first started, standard tools caused corrosion of the titanium alloy. Normal tools were out, and everything changed. The designers thought they started a new technological race, that the next generation of aircraft worldwide would owe a debt to the Blackbird. But it doesn't unfold that way. The Russians developed small bands of high-speed, limited-range fighters, essentially drones because their weapons are controlled from the ground. The pilot only takes off, lands, and maneuvers the plane as close to the target as possible. Apart from Soviet attempts at interceptors, Kelly Johnson's masterwork continues to rule the skies, carrying out secret CIA and U.S. Air Force missions. Back when Kelly Johnson's design team begins work on a U-2 replacement, they first propose a hydrogen-powered space aircraft, which Johnson describes as a big flying vacuum bottle. Because it exceeds the technical abilities of the day, the plan gets dropped. The super sleek and futuristic A-12 bears no resemblance to a vacuum bottle. Though it also stands outside the technical feasibility of its era, it flies into history as one of the greatest engineering feats and one of the greatest aircraft ever built. But by 1990, the Air Force pays a reported $400 million a year to keep its 20 SR-71s operational. And Congress decides it's too much. The allocation is canceled. The Blackbirds are doomed. The aircraft is briefly brought back to life in the mid-90s. NASA continues to fly 2 Blackbirds until 1999. Ultimately, the super-fast manned aircraft gives way to the subsonic unmanned aerial vehicle, or UAV. They spend their entire career in secret. Perhaps someday the details will come out, ending decades of speculation.
The SR-71's final flight provides a fitting end to the story. On March 6, 1990, it speeds from California to Washington, D.C. in under 65 minutes, setting a new world record. Its average speed, over 2,000 miles per hour. There's been no other plane like the Blackbird, and there probably never will be. Futuristic in 1958 and still cutting edge to the end, the Blackbird is likely the greatest aircraft ever built. That, at least, is no secret.